Okay, so let us continue with our explorations about GAN and disentanglement. Hopefully, Judith should be able to send another paper to review pretty soon. Yep, we got a paper. So, in this paper, it's called Guided VAE for Disentanglement Learning. This seems to be in combination with VAE, so it's interesting. Controllable generative model by performing latent representation or disentanglement in learning. The learning is achieved by providing signals without changing its main architecture. We design unsupervised strategy and a supervised strategy and observe enhanced modeling. Unsupervised and supervised seems to be the key point here. Introducing a lightweight decoder that learns latent geometric transformation and principal component. Latent geometric transformation and principal components. So that seems to be in the unsupervised. I'm pretty excited to read this paper. In the supervised strategy, we use adversarial excitation and inhibition. Okay. Seems pretty interesting approach. Let me just highlight this, and I think we got one more paper. So this says this is InfoGAN CR, contrastive regularizer. So this is a regularizer based approach. We have already seen a regularizer based approach before. Training remains challenging after beta VAE, factor VAE. GANs don't have such discovery. Novel regularizer that achieves higher disentanglement scores. Latent traversal. So latent traversal based regularization seems to be the highlight of this paper. We turn intuition into regularization, that is how the latent codes are coupled together and paired. Okay, this seems a very interesting paper to read as well. It's a very interesting approach actually. Yes, disentanglement. People usually look at latent traversals, and therefore there can be a principled way of employing them as a regularization technique. Seems pretty cool. This is a plot from one of the models I'm training. It's pretty old and it's not going good. That is supposed to show attention. Contrastive regularization. This seems to combine ideas from multiple paradigms. We have contrastive laws, we have regularization, which is an optimization condition. We have adversarial training. We also have variational autoencoders. Okay, moving on to this one. I know this paper, pixel gamma autoencoders. Essentially, latent code and recognition path is different priors result in different decompositions. This is a very interesting point they observed. So there are lots of points to take away from this paper. So let me just highlight this. Gaussian, I have not seen other approaches which explicitly disambiguate between the kind of prior distribution and the amount, the type of information that gets disentangled. So this seems to be a very good read. Okay, so we have seen this semi-supervised setting point before as well. So let's note it down and let's search for. Oh, I am pretty certain that yesterday there was a paper I read that had semi-supervision, but maybe I'll get to that later. Okay, this is the next one, a paper called 3D shape induction from 2D views of multiple objects. So the problem of inducing a distribution over 3D structures given 2D views. The addition of a projection module allows us to infer the underlying distribution. The addition of a projection module allows us to infer the underlying distribution without any information or annotation. Mhm. This is a very strong point in this paper, or it seems to me that way. And there is another point. Disentangled representation of 2D shapes into geometry and viewpoint leads to good generative models. And they can do it in an unsupervised fashion. So let's note that thing down as well. The title of the paper is 3D shape induction from 2D views of multiple objects. Mhm. Seems to be one more paper. Yep. So this paper is titled "Elegant: Exchanging Latent Encodings with GAN for Transferring Multiple Phase Attributes". They suffer from three limitations: incapability, transfer unability, and low quality, which can our model can transfer exactly the same type of attributes from one image to other by exchanging certain parts of their encodings. All the attributes are encoded in a disentangled manner in the latent space, which enables us to manipulate how they are encoding in a disentangled manner is a big question that I have. Multi-scale discriminators for adversarial training. I still have question about this, so let's note this point. We have online implementation, which is always a good thing. And let's note paper. about this part. There was another paper that I read about regularization yesterday. Yeah. So this is paper where they did distance covariance based regularization, and this one is latent traversal based regularization. So both approaches are based on regularization. However, one is based on latent traversal while the other is based on the latent relationships. Okay, let's move on to the next one. Intra-class variation isolation in conditional GANs. Current SOTA strong requires strong supervision. New formulation able to learn realistic with continuous semantically meaningful input parameters. I don't know what this is and has the advantage of requiring only weak supervision of binary. This is a very useful feature, to be honest. And beyond just text or image, we coin the method intra-class variation isolation and the resulting network IVGAN continuous control over attributes where precise labels are not readily available. So they're talking about continuous controllability as well, which I'm always interested in while building generative models. For example, given only labels found using a simple classifier, learn a generated face model with controllable lighting. Mhm. Should read this paper. Controllable lighting. I don't understand this term. Let's highlight. Oh, sorry. Continuous semantically meaningful input parameters. Okay, let's move on. There seems to be another paper. Okay, this one is invariant representations from adversarially censored autoencoders. Censored autoencoders. That's something that I have not heard. Okay. Conditional variation autoencoder with adversarial censoring attempts to recover the nuisance variable from the representation. Oh, conditioning decoder on the nuisance variable enables clean separation since they are decombined. Oh, this is very interesting. Theoretically well-founded with information theoretic arguments. I love information theory. So let's add that. Invariance while preserving performance, style transfer and generative sampling. Okay, I don't completely understand this, but I will have to read the paper. But recovering the nuisance variable seems to be the highlighted property here. The next one, AIPNet, Generative Adversarial Pre-training of Accent Invariant. For this purpose, we propose a novel training framework to disentangle accent-invariant and accent-specific characteristics from acoustic features. for which transcriptions are not necessarily available. How they do this will be an interesting thing to read. Mhm. I like this. Accent invariant and accent specific characteristics. So there seem to be commonalities in the papers. Mhm. For example, there are two papers which are about regularization. There are a couple of papers which are about semi-supervision. There is one about hierarchical representation. There is one which uses multiple adversarial networks. There is one which guides unsupervised with supervised, but there is one paper which actually talks about different priors and the kinds of information that those priors learn. Hmm. Okay, this is an old paper. I've already read this. This is the new one. F0 consistent many-to-many non-parallel. Okay. Um, Disentangling speaker identity and speech content using information constraining bottlenecks. This is a very interesting paper. Speaker identity is disentangled. A significant amount of prosodic information such as source F0 leaks through the bottleneck. Furthermore, AutoVC has no control. Oh, this is about a different paper. In this paper, we modified and improved AutoVC to disentangle content F0 and speaker identity at the same time. Mhm. I haven't read AutoVC either, so these will be good papers to read and figure out how they have accomplished this simultaneous disentanglement. This will be a useful thing though, if we are able to disentangle them simultaneously without the leak. But I have been recently reading about the quantum nature of life, and it seems to me that it is probably impossible to prevent the leaks. Maybe the only way we can accomplish anything towards preventing the leaks is by applying path integral formula or proposed by Dirac and made famous by Richard Feynman, but we'll see. Okay. Uh, Continuously adjustable disentangled semantics. New formulation, realistic models. I have read this paper before. Today itself. This is the paper. So yeah, this is a mistake. One of the features that I have in Judith right now is that it randomly samples the papers because Judith doesn't have any idea about which paper is important and which is not. What this means is sometimes I get the papers that I have already seen, While this might appear as a bug, I deliberately left this feature because it tells me if I am awake during this process or I'm just sleeping here. Because if I identify that I have seen a paper before and if I know which parts of these papers are important, then it's a clear signal to me that I am actually paying attention to the work that I'm doing, which is always good. Okay, so Auto VC. I have not read that paper. It sounds similar to vector quantized PAE, but it will be very interesting to check it out. Hmm. Okay, we have the next paper. This paper is encoder powered GAN. We present an encoder-powered GAN, multi-manifold structure and the abstract features of data. Mhm. Encoder to model the manifold structure and invert the encoder to generate data. That seems a pretty different type of paper. Exclude discrete features from the smooth surface modeling and learn multi-manifold data without being hindered by the disconnections. All of this seems to be an important. Also, as encode requires a single latent space to carry the information for all the manifolds, it builds abstract features shared among the manifolds in the latent space. Mhm. Uses a regularizer. Okay. There are a lot of things going on in this paper. I want to know how they model the manifold structure. Inverting the encoder seems to be straightforward. Ex- how it excludes discrete features without being hindered by the disconnection is also something that I don't currently have a grasp of. Let's move on. Generating photorealistic training data to improve face recognition. Novel GAN that disentangle identity from non-identity related attributes. Okay, this is accomplished by training an embedding network that maps discrete to identity latent space and training a GAN condition. Mhm. This is an interesting approach. I like approaches like this. Anything that do interesting things in the latent space. Generating photorealistic training data. Identity latent space. Okay, let's move on to the next one. Oh, this is progress of a project that I'm running, of a program that I'm running. This seems to be the latest paper. Inserting 3D shapes using adversarial networks. Learning probabilistic distribution over 3D shapes given 2D views. The addition of a differentiable, I think we have seen this paper as well. Yep, we have seen this paper as well. Let me see what this is. Seems to be an attention plot. This is an attention plot, but I don't have alignments. The loss function is low though. Okay. This is the paper inferring, right? We have this paper already. Oh, don't we? Reshape. Oh, this is a different paper which looks very similar to this paper. Okay. Yeah, again, what do these people do? Addition of a differentiable projection module. I feel we have seen the same content in the previous paper. I'll check this later. Maybe there is some issue with Judith. Remember this because I have highlighted the projection module. I don't understand it. Okay, so this is essentially a compilation of body of works, and now I can get to go into details.